All right, we're back with another tutorial. In this one, what we're going to do is we're going to conduct some time series econometrics. We're going to use some SAS procedures that are commonly used when conducting time series econometrics. Hopefully this will be useful. I was going to do this offline. So what I was going to do is I was going to take a very large data set and I was going to manipulate that data set to get time series observations. But I feel like maybe in this tutorial it would be useful to go through those steps so you can see how we can take a very large data set and get it into a workable time series data set to conduct the time series analysis. Okay, just let me show you where we're at here. I'm specifying a library name, calling it A. I'm pointing it to this particular directory. And I'm going to create a new SAS data set called data1, and I'm going to set a SAS data set called final stock data 2018 that's located in this directory. For instance, if I click on this directory, there's my final stock data 2018 that's located in that directory. Sorry about that. So let's pull this data in. We've worked with this data set before. It's huge. There's 1.7 million observations, and we're going to try to get this down to a workable format. So watch what I'm going to do here. I'm going to what I'm going to do here is let's look at an interesting problem. I have data here. You can see that I have valuated market returns and the S&P 500 market return. Let me explain what the valuated market return is. For every stock that's available on CRSP, the Center for Research and Security Prices, we calculate the average return, but valuate it or weight it based on the firm's market capitalization. Okay, so you can think of the S&P 500 is also a valuated market index, but it's valuated for the 500 largest firms. This measure of market return is valuated using all publicly available stocks on CRSP. So it's a broader market index. And you can see here that this valuated market return is going to be the same for every stock on January 1st or January 2nd, 2018. That is, this valuated market return, there's 250 trading days in 2018, and this valuated market return is going to be different for every day for stock JJSF. And then once this ticker changes, the valuated return returns. Does that make sense? So every stock on this particular day is going to have this valuated return. Likewise, every stock on this particular day is going to have this valuated return, and so on. So what I want to do, let's do something here where I want to examine the time series effects of the valuated market return. Okay. But I also want to get the total trading volume for all publicly traded stocks. So maybe what we could do here is we could get the total trading volume for all publicly traded stocks to see if there's a relationship between trading volume and the valuated market return. Okay, so I've got a huge data set. I got 1.7 million observations. I've got 8,000 stocks, and I've got to get this down into a workable time series data set. I'm going to do this through a series of procedures in SAS, which is proc means. So watch what I'm going to do here. I'm going to sort data1 by ticker. Actually, I'm going to sort this by date. Okay, and then I'm going to run a proc means. Data1, no print, and I want to basically sum up all of the trading volume for every stock on each day, as well as the shares outstanding, because what I'm going to do is I'm going to calculate a measure of turnover, share turnover, that we've used in previous tutorials, and I'm going to run this by date. I'm going to create a new SAS data set called data2, and I'm going to sum all of the volume and shares outstanding. Okay, let me explain what I've done here. I'm sorting this data set, 1.7 million observations that consists of both stocks and days during 2018. And then I'm going to run a proc means procedure where I'm basically going to take the sum of all trading volume and all shares outstanding for each stock on each day, and it's going to generate a time series data set for me. So let me print this out, and you can see what the data set looks like. This output out equals data 2 procedure here under the proc means is basically going to sum volume and shares outstanding and put it into a new SAS data set called data 2. SAS works on this pretty quickly here, and you can see that this is the total amount of trading volume for all of the stocks in my sample on that particular day. Likewise, this is the sum of all of the shares outstanding on that particular day. I've got to do something here. I'm going to say data 2 set data 2. So I'm going to create a new SAS data set called data 2, and I'm going to set the SAS data set data 2 that I just created in the proc means procedure. And what I want to do is I want to create a new variable called shares, which is equal to shrout times 1,000. Remember, shares outstanding is in 1,000. And then I want to create a measure of share turnover, which is equal to the volume divided by shares. And let's just keep the date and this measure of turnover as my variables in this new SAS data set called data 2. Go ahead and run that. So here is the share turnover for the entire market on each day during 2018. Let's create another time series data set. Let me go back up here and we can take a look quickly. What I want to do is I want to grab this value weighted return, for each day during 2018. I can do this a couple of ways. I think the easiest way is to do the following procedure. I'm going to proc sort data 1. I'm going to output a new data set called data 3, and I'm going to say no dupe key. Basically what happens here is I don't want duplicate values of this value weighted return on a particular day. So I'm going to say by date. So in other words, this is going to take the first value weighted market return on this date and put it into a new data set. It's going to take the value weighted return on the second date and put it into that same data set, and so on all the way till December 31st, 2018, and that's it. I will only have observations for each day in December. I know that this value weighted market return is the same for each stock on each day, but this proc sort no dupe key procedure gives me what I'm looking for here. Let me print this just to make sure it worked. And what I should have here is just around 250 observations. Okay, and it's that first ticker. If I go to the log SAS log thing, there's the 250 observations. So this SAS data set is only 250 observations big, and it just consists of the ticker symbol JJSF. Watch what I'm going to do here. I'm going to say data 3 set data 3. So I'm creating a new SAS data set 3, setting the old SAS data set 3. I'm going to keep my date and my value weighted market return. So SAS data set 2, data 2, consists of turnover for each date. That's share turnover for the entire market on each day. And SAS data set 3 consists of my value weighted market return on each day. Okay. Now what I'm going to do is I'm going to merge these two data sets, data 2 and data 3, by date. I already know that data 2 and data 3 are sorted by date, but I'm going to do this again anyway just to re-emphasize when you're merging you have to sort on the variable that you're merging by. I'm going to create a new SAS data set called data 4, and I'm going to merge data 2 and data 3 by date. When I do this, it's going to give me a new SAS data set called data 4 that gives me share turnover as well as the value weighted market return all in the same data set. So now I have a time series data set that I can conduct some time series analyses with. Okay, so let's now start the time series econometrics portion of this tutorial. What I first want to introduce is I want to introduce the principle of stationarity. The time series econometricians that are listening to this will understand this concept. It's an important concept when you're conducting time series analysis. Stationarity basically suggests that the statistical properties such as the mean, the variance, and stuff are constant over time. Okay, so that's needed. Stationarity is needed when you're conducting time series econometrics. So what I want to do is I want to test for stationarity, and one way that we can do that is we can conduct something called an augmented Dickey-Fuller test that tests for unit roots. The code for that is proc autoreg data 4, and my model statement is going to be the valuated market return equals, and then in my model function what I'm doing is I'm testing for stationarity. And you can see that the stationarity variable, when I type that in, it populates blue because SAS recognizes it as part of the proc autoreg procedure. And then to conduct the augmented Dickey-Fuller test, I'm going to say ADF equals 1. So what that does is this runs a regression. Let me tell you what this regression runs. This runs a regression for the market return. Let's call the market return RMT. It runs the following time series regression. A is the intercept, B is the slope, and the independent variable of interest is the market return in time period T minus 1. Okay, so it's running that regression right there. It's testing for stationarity. It's also going to give me the estimated parameters of this procedure. This is called an AR, an autoregressive model, an AR1 model because I'm only including one lag. If I change that to 2 or 3, then I would include, this would be B1, 1 day lagged market returns, plus B2, 1 day lagged market returns for 2 periods, plus B3, market returns T minus 3, and so on. Okay. So let's just do this for an AR1 model. I run the proc autoreg. Generated some plots for me. I can say plots equals none in the data step to get rid of those. Okay, there it shows the intercept here, and this variable, this is the this row measure under the trend row. When I say row, I mean RHO, is telling me whether or not there are unit roots. If this variable is significantly negative, and it is, the p-value is less than 0.0001, that suggests that the time series for evaluated market returns is indeed stationary, which is useful. Watch what happens instead of using the evaluated market return. What happens when I run this for turnover? So if I run the same model using turnover instead of evaluated market returns, this is an AR1 process for share turnover. Let's see if the time series for aggregate turnover is stationary. And it looks like it is. You can see that it's negative. It's not near as significant. When you're working with time series data, sometimes the time series observation that you're looking at won't be stationary. So what you're going to have to do is you're going to have to difference that. How would I difference turnover? So what I'm going to do is, if you look at the data here, I'm going to quickly print data set data 4. How do I difference that? To take the difference of turnover, what I'm going to do is I'm going to use a lag function inside of a data step to lag that turnover. Let me explain. I'm going to say data 5, set data 4, and I'm going to lag turnover using that operator right there, lag 1, turnover, proc print data 5, and when I run this data step where I conduct or I lag that turnover, it's going to produce another. Do you see what's happened here? It produces another column that lags turnover 1 period. Okay, so then inside of that data step, I can create a new variable called diff turnover, which is going to be equal to turnover minus lag turnover. Okay, so the way to get stationarity, if your time series variable is not stationary, is to difference that. Take the first difference of that. It's going to produce another column here that's going to give me my diff turnover. Now watch, when I run proc autoreg one more time for SAS dataset data 5, and instead of looking at the value weighted market return or looking at turnover, I instead look at the first difference turnover, an AR1 model for the first difference turnover. When I run that, again, I forgot to hit plots equals 0. Notice that my row is negative 612. That's highly significant. Remember, in the previous version when I didn't difference it, it was still significant. I still didn't have unit roots. I still had stationarity, but it was much less stationary. It wasn't non-stationary, but it was much less stationary. So we could say that both turnover and the first difference turnover is stationary. When a variable is stationary after you've differenced it, it's called differenced stationary. So turnover appears to be stationary, but when you're working with time series observations where the level is not stationary but the difference is, it's called difference stationary. So that gives us the ability to test an AR1 model and get estimates for an augmented Dickey-Fuller test. It might also be useful to conduct a vector autoregression. Time series econometrics vector autoregression is widely used. It's used both in macroeconomics to forecast GDP. It's also used in finance to try to identify causal movements when two time series move together across time. Let's do both of these. So what I want to do is I want to use the proc VARmax procedure in SAS. This allows me to do a couple of things. First, it allows me to conduct it allows me to forecast using a vector autoregression. So say I have two time series, for instance, I have turnover as well as value weighted market returns. I can look to account for the possibility that one variable, say turnover, is causing value weighted market returns, changes in value weighted market returns. So let's say proc VARmax data equals data 5. I'm going to plot something called impulse response functions. Okay, my model is going to be fairly simple. I don't know whether or not turnover is causing market returns to move, or I don't know whether market returns are causing turnover to change. Do you understand? So we have some inherent endogeneity in these two time series, and this time series econometric technique will help us learn here. So what I'm going to do is I'm going to include the value weighted market return. Notice I'm not saying equals. I'm just including both of these. In other words, I'm treating both of these two variables as endogenous. I'm going to include one lag, so P is the number of lags. I don't want to include any intercept. And let's look at this for 20 days. Let me print the impulse response functions. This will generate several impulse response functions. I'll talk about those once we get to the output. Okay. And now let me do something here that I think is going to be useful. So I'm going to put another line of code here that says causal group 1 is going to be equal to the value weighted market return, and group 2 is going to be equal to my measure of turnover. Okay, so what this line does, this last line of code, it conducts inside of the vector autoregression a Granger causality test that tells me whether or not group 1 is caused by group 2 or whether it's just caused by movements by itself. Okay, so that will give me output for a Granger causality test, which might be useful to conduct some time series observations. I'm going to use an ODS function. I'm going to output simple impulse response functions. I'm just identifying what the output should look like if I ever want to reference it here. Okay. So what this is going to do, let me explain econometrically what's happening here. So I'm running two regressions simultaneously. First, I'm running market returns as a function of A plus, let's call this A1 plus B1 lagged market returns plus B12. Let me call this slope coefficient B11, B12 turnover in time period T minus 1. And then I'm running another model simultaneously that is my turnover in time period T equals A2 plus beta 21 return on the market in time period T minus 1 plus beta 22 turnover in time period T minus 1. So I'm estimating these two equations simultaneously. I'm getting parameter estimates here for parameter estimates for each of these coefficients. Okay. So basically what this VAR is doing, it's allowing both value weighted market returns and turnover to move across time together. And then what the impulse response function is going to do, it's going to exogenously shock this error term. Recall from your econometrics class that the error term should be orthogonal or independent of the independent variables used on the right hand side of the equation. So I know that whatever is in this error term is exogenous to these independent variables. So what I'm going to do is I'm going to impose a one standard deviation shock in each of these error terms, E1 and E2, and then I'm going to look at the effect after the relationship between market returns and market turnover has been established. I'm going to look at the effect of what happens to, say, market returns for a one standard deviation shock in this error term E2. Likewise, I can look for what happens to a one standard deviation shock to E1. I can look at how a one standard deviation shock to market returns that is exogenous to this time series relationship, what a one standard deviation shock does to turnover. Does that make sense? So when I run these lines of code, I get an error. This is probably useful. Let's see here. Oh, do you know what I've done here? So I needed to, I put a semicolon here, and it doesn't need to be there. Okay, so that's actually useful. This might be an error that you run into. One too many semicolons or not enough semicolons. It seems like it's running now. Okay, so here are my VARs. Here are the of course, SAS produces multiple types of impulse response functions. It will produce orthogonalized impulse response functions. It will produce accumulated impulse response functions, and it will produce simple impulse response functions. Here are the actual impulse response functions. Let me just explain what this looks like. So this is the variable response to the variable response of the value-weighted market return to a one standard deviation shock either in market returns or in turnover. Does that make sense? So look at what happens. If I shock error term E1, okay, if I shock error term E1, right, then it shows that value-weighted market returns, that is a positive exogenous one standard deviation positive shock to E1. That shows that in time period 0, the orthogonalized impulse response of value-weighted market returns is positive, and it stays somewhat positive, but reverts back down to 0 very quickly. Let's look and see if the simple impulse response function also has the same properties here. Yeah, so we can see it a little bit better in the simple impulse response function. The idea here is I'm imposing a 1 standard deviation shock on E1 in this column, and you can see the next period valuated market return is positive, 0.00412. Notice that standard deviation is pretty high, so I can't really make strong inferences that that's a significantly positive shock. But you can see that after a 1 standard deviation shock to E1, the valuated market return is positive and remains positive for a period of time. Eventually it reverts back down. Sorry about that. Eventually it reverts back down to 0. Okay. You can see it slowly. 9 days after, it's down to 0.00078 and so on. Look at what happens when I shock turnover. Okay, so this is a 1 standard deviation shock to E2. Okay, so let's impose a positive 1 standard deviation exogenous shock to the air term in E2, and let's look at what happens to market returns. You can see that if I impose this 1 standard deviation shock to market turnover, it looks like valuated market returns becomes negative, and then it reverts back up towards 0. You see it takes a long period of time, but it reverts back up towards 0. Notice again the standard deviations are huge, so I can't really make any inferences regarding the significance of the response in valuated market returns to an exogenous shock in turnover. However, it appears, and I guess I could scroll down here to the graphics to make stronger inferences here. Let's see here. These are accumulated response to an impulse in valuated market returns. What we were looking at is an impulse response to share turnover. Look, you can see here, we had just talked about this. When you shock E2, positive exogenous shock to the air term E2, that's going to cause valuated market returns to be negative, and then you can see that they slowly revert back to 0 over time. Okay, so these are a few procedures that SAS uses to conduct time series econometrics. Maybe this tutorial didn't make any sense to you because you don't understand time series econometrics. I'm not a time series econometrician by any means. However, SAS has apparently hired some time series econometricians to allow us to use procedures for those of you who want to conduct this in SAS.